Hey guys, I'm doing this video today to show how I made a solid tool post base for my mini lathe. As a lot of you know, the compound slide reduces rigidity in these small lathes. 90% of my operations don't require a compound anyway, so I'm going to keep it set aside for the other 10%. And to start out with, I measured the height of the current base, and I'll be making the solid one to match so that my tool heights stay the same. I am by no means a real machinist. I just enjoy this as a hobby. The end product will be very basic and is all done on the lathe and the drill press, but I'm pretty happy with how it turned out, and I was actually able to hit my dimensions pretty closely. So sit back and enjoy the video, and hopefully, you see something in there that may spark your curiosity or give you a good idea on how to do yours. So I've made a quick, simple little drawing here. As you can see, I'm making the base 36.51 millimeters tall to match my current base that's on the machine now. The width will be 64.85 millimeters, and the length will be 66 millimeters. My holes to match the slide mounting will be 16 millimeters apart from each other from the center. The center hole will be drilled and tapped to accept a 10 millimeter post, and the two small holes to each side will be drilled for 6 millimeter socket head Allens to go through and engage the threads in the cross slide. These holes will be counterbored so that the Allens will be below the surface. Now with all that said, let's hog off some aluminum and get started. This is a really big chunk of aluminum cylinder that I got at a local scrapyard. I have a lot to cut off of it just to even get it close. And if you're watching this, you know a small lathe would take forever to remove much material. So I'm going to get to work on this with a bandsaw and get it chopped down at least close to the size that I'm going to need. Now that I have a pretty good chunk of it lopped off, I've got my lines scribed in there for the initial shape, so we're going to go ahead and start getting the basic outline done. So right here I got the part chucked up in a 4-jaw chuck because of the odd shape and the finish that I'm trying to put on it. The 3-jaw just really wasn't big enough to do it. I used a square and a dial indicator to get the part running true to the ways. It took a little trial and error to get everything square, but it came out really nice. Since I don't have a DRO on the lathe, I'm using a dial indicator to measure my depth of cut with the compound. And I got to say, it's pretty ironic that I'm using the compound for the fine feeding on this project. That is definitely not lost on me. Right now, I'm just trying to get all the surfaces square. After I have the basic shape squared up, I'll start working on dimensioning. And that, my friends, is what happens when you don't have your carriage locked down good and you bump the carriage feed. Here you can see me getting the piece squared up with the ways on the lathe using the dial indicator. Now, where I did make a mistake here, I got it dialed in to where I don't know how to quite explain it, but I got it where the piece was pointing down the ways, perfectly parallel with the ways. But what I didn't do in this step was make sure that it was straight with the nose up and down out in front. Of course, I didn't really have a straight edge to work off of at that point yet. So what I did is I went all the way around the piece, getting everything parallel with the ways, the way I'm showing you now. Then I came back, and of course I had, I think you'd call it a parallelogram, where it was out of square a little bit. Then what I did is I took a square and then drew lines on it, and then set the square on the ways um, where the square is pointing up, and then got the piece lined up so that the nose that's hanging out the end was parallel with the ways in that direction as well. and two different planes. But anyway, that's what I wound up having to do, is just use a square sitting on the ways, laying up the side of the material. Now it's time to get these holes drilled. I'm going to start out with the center. I'm just using the center drill real quick to get a pilot started. And you can see this rookie camera work that I have my arm right in front of the camera while I'm trying to drill the hole. But we'll get these 3 holes drilled and measured in and get this thing ready to mount. Now right here, I went online and looked to see what the pilot drill bit size needed to be for a 10 millimeter tap. I didn't have the exact one, so I got it as close as I could, and it worked out just fine. So right here, I drilled about halfway through the block, and now I'm tapping 10 millimeter hole for the stud that comes up top that holds the quick change tool post holder. So I ran over here real quick, and I'm measuring the little stud that sticks up out of the base plate. It's measuring 8 millimeters. So what I did is I found the closest drill bit. I need to get a really good drill index. I don't have one yet. But anyway, I found the closest drill that gave me a little bit of wiggle room on it. And you see this one's dialing in at 8.35, around 8.3, 8.2.5. But anyway, that gives me a little wiggle room on it. So I'm going to go from there. So now I'll go ahead and get these 2 smaller holes drilled either side of the center hole. You could see on the base plate over there on the carriage where those 6 millimeter bolts are going to go through and tie everything together. Now these holes are drilled just slightly oversized, so the bolts go through them easy. So they're just through holes, and then I'll countersink them, counter bore them after I get these holes drilled. Now I'm measuring the depth that I need to make my counter bore and the diameter. So it's running almost 6 millimeters deep, and that's showing about 10 millimeters around. So I'm going to pick drill bits accordingly just to give me a little more room there. After that, I'm going to go ahead and start drilling the counter bores. And all I'm doing is trying to get the head of the cap screw below there. So I'm just going to use my depth gauge and really just, instead of sticking the screw in there and seeing how deep it is, I know how deep it needs to be, so I'm going to shoot for that just to get them about 2 millimeters below the base, or below the top of the block, and then make sure they match. So now we got the main part of it done, we'll go ahead and fit it up and see how it looks. And I think it turned out pretty good. I need to make some soft jaws because when I was holding the part and turning it in the lathe, I put marks on the aluminum because it's pretty soft compared to those jaws. And I used to have a set of soft jaws, and I don't know where in the world they went. But anyway, I need to get back to that. But yeah, she's looking really good. Getting her put back together here, and then we'll turn a little bit with it and see how it does. I don't know if you can see it really well in the video, but I've got a poor man's DRO I put on there, which is a little caliper mounted to the cross slide. And what I did is I just turned it in 5/1000ths. So we take a 5/1000ths pass on this piece of steel. Well, I think this is going to work out well. It's a very simple upgrade and has a rather large impact on the finish. So I hope you enjoyed the video and found something useful. And if not, oh well, because I don't do this for money. Until next time.